Good day viewers, you're welcome to my YouTube channel. This video explains the differences between three major units of concentration: molarity, formality, and molality, and also provide clear explanations and examples to help you master these terms, as well as debunk common misconceptions in their usage. Concentration is defined as the amount of a substance dissolved in a particular or specific volume of solution. So concentration explains the amount of a substance in a given volume of solution. We'll start first by explaining the differences between molarity and formality. Now, concentration in terms of molarity is the moles of solute or amount of solute per volume of solution in liters, while formality also is given as the moles of solute per volume of solution in liter. Now, if you observe very well, both molarity and formality have same formula. All right, and in calculation, most times formality and molarity are confused for each other because they have same formula. But there's a subtle difference between molarity and formality. First, molarity is the concentration of a particular species, and also it takes into consideration the dissociation or chemical changes in the solute, which is it is based on the number of moles of the ions formed. While formality is the substance total concentration regardless of its specific chemical form. It does not take into consideration the dissociation of chemical changes in the solute. Now, what this means is this. Let's take, for example, calcium chloride. In an aqueous solution, it ionizes to give 1 molecule of calcium ion plus 2 molecules of chlorine anion. Now, molarity has to do with the concentration of a particular species. That means it takes into consideration the dissociation or the chemical changes of the compound. It is based on the number of moles of ions formed. All right, while formality is the concentration of the compound, the total concentration of the compound. All right, it is the substance total concentration, while molarity is the concentration of a particular species. Molarity is only equal to formality if the substance do not ionize in water. For example, let's say glucose. Glucose dissolves in water but do not ionize or dissociate in water. So in the case of glucose, the molarity is equal to the formality. For example, let's say we dissolve 0.1 mole of glucose in 1 liter of a liquid or 1 liter of water. The answer we'll get is 0.1 mole of glucose and also 0.1 formal of glucose, because glucose do not ionize or dissociate in water. So molarity and formality can only be the same if the substance do not ionize in water. But if the substance ionizes in water, for example, let's say calcium chloride ionizes in water to give us calcium ion and chlorine anion. All right, if the substance is dissolved in water, it ionizes to give you calcium and chlorine, and as a result of that, the formality and molarity are not equal. All right, so in case of an ionic compound, the molarity is not equal to the formality. Now, for example, let's say we dissolve 0.1 mole of calcium chloride in 1 liter of water. All right, the formality is the concentration of the total compound. All right, so if you divide this, the formality is 0.1 formal of calcium, but the molarity is different in this case. The molarity gives you the concentration of the specific ion. For calcium, we have just 1 mole. All right, so for calcium, the molarity is 0.1 mole for calcium ion, but for chlorine anion, we have 2 molecules of it, so we multiply 2 with the concentration, so that gives you 0.2 mole of chlorine ion. All right, so why formality gives you the total concentration, which is 0.1 formal of calcium chloride. The molarity takes into consideration the number of moles of ions in the solution. So the molarity is 0.1 mole for calcium and 0.2 mole for chlorine anion. Now let's take one simple example here. Now this question says, calculate the molarity and formality of a solution made by dissolving 5 grams of calcium chloride in 500 ml of water. All right. Now we know concentration in terms of molarity or formality is given as moles of solute over volume of solution in liters. All right. Now let's start first by looking for the moles of solute. You know from calculation, mole is given as mass over molar mass. All right. So what's the mass here? We have 5 grams. So we'll start first by looking for the formality, because formality gives you the total concentration of the compound. So the mass is 5 grams over the molar mass of calcium is for calcium chloride is 110.98 grams per mole. All right, so when you divide this, you have 0.045 mole. All right, so that's the moles of solute. It is 0.045 mole over volume of solution. The volume of solution is 500 ml. All right, but take note, our volume is in liters, so we'll convert 500 ml to liter by dividing with 1000. So if you do that, you have 0.5 liter. All right, so when you divide this, you have 0.045 mole divided by 0.5 liters. The answer gives you 0.0902 formal. So this is the formal concentration of calcium chloride. All right, but if you want to look for the molarity, take note, molarity takes into consideration the dissociation or the number of each species in the solution. You know that calcium chloride ionizes to give you calcium ion plus 2 molecules of chlorine anion. All right, so now let's go. The molarity is given as amount or moles of solute, which we calculated to be 0.045 moles over volume of solution also, which is 0.5 liters. So you divide this, you have 0.0902 mole of calcium ion, because we have just only 1 mole of it. All right, but the number of molecules we have for chlorine here is 2, so we'll multiply 2 with this concentration. If you do that, you will be having 0.180 mole of chlorine anion. All right, so in summary, our formality in regards to that question is 0.0902 of calcium chloride, and the molarity is 0.0902 mole of calcium ion and 0.180 mole of chlorine anion. So that's the difference between formality and molarity. Take note of this. Molarity tells you the concentration of the individual ions in the solution, while formality tells you the concentration of the total ion. We'll go further to explain the difference between molarity and molality. As you know initially, molarity gives moles of solute per volume of solution, while molality is moles of solute per kilogram of solvent. Now, in terms of the formula, the difference between molarity and molality is that in molality, the solvent is expressed in kilogram, while in molarity, the solution is expressed in volume. Now, molality does not depend on temperature. It is unaffected by temperature, while molarity is affected by temperature. And molality is used when dealing with situations where temperature changes are involved. This is because it is unaffected or independent of temperature, while molarity is affected by temperature because it depends on volume. And you know that volume expands or contracts. According to Charles, the volume varies directly to temperature. All right, when temperature increases, volume increases, and when temperature decreases, volume also decreases. So, because volume is affected by temperature, its molality is used in situation where there's temperature changes. So by using the solvent mass in place of the solution volume, the resulting concentration becomes independent of temperature. Let's take one example. Example number 1, it says calculate the molality of 30 grams of sodium hydroxide in 500 ml of water. Take the density of water to be 1 grams per ml. Now you know concentration in terms of molality is moles of solute over kilogram of solvent. All right. So now let's start first by looking for the moles of solute. We know that mole is equal to mass over molar mass. Here the question says calculate the molality of 30 grams. So the mass is 30 grams over the molar mass of sodium hydroxide, which is 40 grams per mole. When you divide this, you have 0.75 mole. So the moles of solute is 0.75 mole. And we'll go further to calculate the kilogram of the solvent. Take note from the question we are given, the solvent is in mil, 500 mil. All right. Now, with the density of water, we can convert this 500 mil to grams. Now, from the density, 1 gram of water, 1 mil of water weigh exactly 1 grams. All right. So 500 mil will be equivalent to how many grams? So mil going to mil, 500 mil will be equivalent to 500 grams. All right. But take note, our solvent is in kilograms. So we convert 500 grams to kilogram. And you know that 1 kilogram is equivalent to 1000 grams. All right, so if 1 kilogram is equivalent to 1000 grams, 500 grams will be equivalent to how many kilograms? We cross multiply, S equals to 500 over 1000 to give us 0.5 kilogram. All right, so the solvent is over 0.5 kilogram. So when you divide this, your answer becomes 1.5 mole per kilogram or 1.5 molality. We'll go to the next example. It says find the molality of 30% hydrochloric acid. Now, the molar mass of hydrochloric acid is 36.46 grams per mole. Now, one thing you need to take note of is this. Here, we have a concentration expressed in percentage, 37.0% weight by weight. What this means is that we have 37.0 grams of HCl in 100 grams of solution. All right, so out of the 100 grams, 37.0 grams is HCl, while the remaining one, which is 63.0 gram, is water. When you join this together, it gives you 100 grams. Okay, so that's what 37 weight per weight means. Okay, it means 37% of the substance is hydrochloric acid, while the remaining 63.0% is water. All right, so this is the mass of hydrochloric acid, while this is the mass of water. So now let's go over to calculating the concentration in molality. All right, concentration in terms of molality is moles of solute over kilogram of solvent. All right, so from our formula there, we have mole is equal to mass over molar mass, where the mass is 37 grams and the molar mass of hydrochloric acid is 36.46 grams per mole. So you divide this, you have 1.01 mole. So our moles of solute is 1.01 mole. And the kilogram of solvent, all right, aside the 37, the remaining side of it is water, which is 63 grams. So we'll convert 63 grams to kilogram. And you know that 1 kg is equivalent to 1000 grams. Then 63 kg will be how many? 63 grams will be how many kg? Which is equal to 63 over 1000 to give you 0.063 kg. So our kilogram of solvent is 0.063 kg. When you divide this, you have 16.0 molality as the answer. Thanks for watching. Please do well to subscribe, like, and share this video.